Well, good morning to you fine seventh graders. Are you ready for another fun, exciting, and fantastic video about mathematics? Mrs. LeBeau should have or given you some note paper to take notes on whilst I do this. So if you don't have that, make sure you get it because it will be greatly helpful for you. So here we go. Take a look at this. Today, ladies and gentlemen, we talk about a heavy hitter in math, and that is similar triangles. And more so than that, it's similar triangles actually and kind of story problems. Where in the world did that color come from? Similar triangles and story problems. Story problems. I cannot emphasize to you enough that you must sketch these out. If I haven't said that enough today, I will say it again to you. And the thing to remember about similar triangles is that it's that little thing that says corresponding sides are proportional. Not really liking how thick my font is here. Are proportional. A couple things you know about similar triangles, kids, is that first of all their angles are equal, or the corresponding angles are equal. And if you go, well, but that part doesn't really matter about it. But what does matter is that the sides are proportional, which means you are going to use a ratio box to solve these. Okay, or proportion box, whatever kind of box you want to call it is what you're going to do. So here's the deal. Generally speaking, if you were given a problem like this, you know, they would not give you this all drawn out, but they helped you out because it's an example problem, and that's kind of how we start. So this Mayor Cruz wants to know the height of a flagpole. She stands with a meter stick in a vertical position and finds that the length of its shadow is 120 centimeters. At the same time, the shadow of the flagpole is 30 meters long. How tall is the flagpole? All right, so after all the smoke clears, when all is said and done, basically we sketched this problem based on the information that they gave us, and the information was this. Okay, we've got a flagpole. There it is. All right, she wants to know the height of it, so she doesn't know. This is what you don't know, but we know a whole bunch of other stuff. Okay, she stands a meter stick in a vertical position and finds that the length of its shadow is 120. So here's my meter stick. And notice the book changed a meter into 100 centimeters. Okay, and the thing you have to imagine about this is this. Where does the triangle come from? Well, the triangle comes from the fact that we have a sun. Ain't that pretty? And that sun the sun shoots out rays that cast shadows. So here is your one triangle, and that sun also shoots out a ray that casts a shadow over here. So triangle number 1 and triangle number 2 are similar triangles because they have the same angle here. Now those are right angles, and they also have the same angle here. Okay, but you might say it shines at different degrees, but it doesn't really. The sun is so stinking far out there that the little bit of difference in that degree is negligible. Okay, so given that information here, first of all, if she sticks the meter stick in the ground, it casts 120 centimeter shadow. We have the pole already here. It casts a 30 meter shadow. We can measure all three of those things, but really it's really hard to measure the height of this flagpole. Okay, so here is the deal and how you solve that. Oops, let me scooch down here. So the book kind of redrew the things without all the gobbledygook right here, but your triangles could look like this. Okay. Here's basically what you're going to do. You need to draw a ratio box. So here's my ratio box. And this is how we would label such things. we are talking about, we only need these parts here. Okay, we're talking about two cases here. What are we comparing? We are comparing the height of the triangles to their shadows. And you have the smaller triangle and you have the bigger triangle, and you just need to fill in the blanks. The height of the small triangle is right here. It is 100 centimeters. All right, the height of the small triangle is 100 centimeters. The height of the big triangle, we put the letter P there, we don't know. That's what we're looking for. Okay, this is 100 centimeters. The shadow of the small triangle is 120 centimeters. Okay, and then the shadow of the big triangle is 30 meters. Okay, now just know, okay, in this small triangle we're talking centimeters, and the big triangle we're talking meters, and we can kind of do that. It's really not that difficult of a thing here. You can keep them labeled like that. So the question is this: how do I go from 120 down to 30? Okay, well, hopefully you can see that 12 divided by 3 is 4, and that's what this would be. 120 divided by 4 is 30. So I am going to divide 100 by 4, and that is 25. Again, remember, this is in meters. Okay, the height of the pole is 25 meters tall. 25 meters tall. And that, ladies and gentlemen, is just as easy as it gets. The problems do get a little tougher. Maybe I should try to, hold on a second here. I am not quite ready with this here, but I should have had another example for you. I'm going to try to find one real fast. Bear with me. Sing yourself a little song, maybe a song of sixpence, pocket full of rye. Let me see here, copy lessons. Let's see if I can find something here. Lesson 65. 63, 65. Yeah, here. I'm going to snag one here, and you can kind of follow along with it here. I mean, sometimes it's just a little tougher. Now maybe we'll just do letter A. Let's do letter A, and then we'll call it a day. Pardon the rhyme. I think that's too big, too small. Okay, so here we go. Let's read. This one has no pictures drawn for us. We will have to do it ourselves. Trevor took big steps to find the length of the shadow of a big pine tree in the front of school. He estimated that the shadow was 16 yards long, or about 48 feet. He also stepped off the shadow cast by a two-story school building, estimated that its shadow was 18 feet long. Trevor thinks the building is 24 feet tall. How many feet tall is the big pine tree? So here we go. Here's how we organize our thoughts. Okay, first of all, Trevor is talking about here. We'll make this green. He's got a big pine tree. Look at that sweet looking pine tree. And it doesn't really matter what this shape is because we are going to make it a triangle. Well, here, we'll make the line go through the, here's the height. Here's my big pine tree. What do we know about the big pine tree? We don't know how tall it is, but we know that the shadow was 48 feet. So if you think about the sun shining over here, it cast a shadow, and that shadow is 48 feet. Okay, and then he went over and found a two-story school building. So here's my school building. And it doesn't really matter how you draw the school building. We'll put little windows in here. I guess every school building has a flagpole with the flag and stars and all that sort of stuff. But he knows that its shadow was 18 feet. And that's still that same sun's ray kind of shoots down on it. Boom. And he thinks that the building is 24 feet tall. So there are my two triangles. I didn't really draw them as nicely as I should have, but you've got this triangle, which I would guess I would label as my big triangle because the tree is taller than the building. And then you have this triangle over here, which I would label as my small triangle. Again, it's just a matter of making ratio boxes here, proportion boxes. You could do it the exact same way that we did the last one. And I try to keep things consistent. We got the big triangle, we got the small triangle, we got the big triangle, and we're comparing its height to its shadow. So the height of the small triangle, this is the small one, was 24 feet. Okay, the shadow of the small one was 18 feet, right here. And then looking at the big one, the height of the big one here is what we don't know. It's a tree, so let's make that tree. But the width of the big one down there is 48 feet. So I am looking for the letter T. Now, this one doesn't necessarily look like it's going to work out because nothing times 18 is 48. So here is where you just have to remember, you are just making equal fractions here. So I'm going to rewrite this down here as 24 over 18 equals what number over 48, and work it kind of from there. And the first thing I would do, ladies and gentlemen, on this is, because this is made up of a bunch of even numbers, I'm going to reduce this and see if that doesn't help me out. If I divide them both by 6, I get 4 over 3. Oh, and look, guess what? 3 times what is 48? If you divide that out, you would get times 16. So the answer to my top would be whatever 4 times 16 is. And if you did the math, 16 times 4 is 64 feet. So I know that the big triangle is, the tree is 64 feet tall. And voila, and shazam, and kaboom, and pow. That would be how you would do that ratio proportion boxes with shadows in the real world. So, ladies and gentlemen, thanks for stopping by. I'll try to throw you a couple problems maybe you can do and have some fun with that. Have a good day.